In this presentation, I'm going to explain previous GATE questions and answers for the year 2021. And the topic covered is power electronics. Now let us see the first problem, 2021 GATE question that carries 1 mark. First one. In the circuit shown, the input voltage Vi is a sinusoidal AC voltage having an RMS value of 230 volt plus or minus 20%. That is, this input voltage is 230 volt plus or minus 20%. And the worst case peak inverse voltage seen across any diode is any other out of this four or no any diode. What is the peak inverse voltage PIV? That's a question. Therefore, this is a circuit diagram in which this is a single phase bridge circuit and input voltage is equal to 230 volt plus or minus 20. This is RMS value, and for the 230 volt plus or minus 20, RMS value means the magnitude wise 230 volt plus or minus 20% of 230 volt. That is equal to 20% of 230 volt. That is 46 volt. Therefore, 230 plus or minus 46. Therefore, the RMS value will be of the input voltage will be varying, or that ranges are 230 plus 46 and 230 minus 46, or the RMS value can change from 276 volt to 184 volt, or the maximum magnitude can be into root 2. Therefore, 276 into root 2 or 184 into root 2. Therefore, so the supply voltage can be from 184 into root 2, that's a maximum value sin omega t, to 276 root 2 sin omega t. Therefore, the peak value, that is when, for example, here when these two diodes are conducting, see, as it is marked as D1 and D2 are conducting, as D1 and D2 are conducting, that will be reversed, that voltage will be reverse biasing other two diodes, or D3 and D4 gets reverse biased, and the maximum reverse voltage that across the diode which are not conducting, that will become is equal to the maximum reverse voltage, reverse voltage in diodes Vm, that's equal to the maximum value, that is the voltage that is coming across the diode equal to this one. Therefore, the reverse voltage that is coming across the non-conducting diode, that is given by Vd3 equal to Vm sin omega t, where max peak value of Vm is equal to 276 root 2. Therefore, the PIV, the peak inverse voltage of the diode, each diode equal to 276 into root 2, which is equal to 390.32 voltage. Now let us see the second problem, that is in 2021 GATE question that carry 2 marks. Consider the boost converter shown this figure. Switch Q is operated at 25 kHz with a duty cycle of 0.6. Assume the diode and the switch are ideal, that is to be ideal. Under steady state condition, the average resistance R as seen by the source is that much. How much? That is round off to the 2 decimal places. Now, this is operated at 25 kHz and the duty ratio equal to 0.6, and the resistance that is here, it is shown 10 ohm. How much would be the value of the resistance reflected at the input side? That is the question. Now, to find out that, for this is a boost converter, and in boost converter, the basic relation between the average output voltage and average source voltage or input voltage is given by V0 by Vs equal to 1 by 1 minus d. V0 by Vs equal to 1 by 1 minus d, or Vs equal to 1 minus d into V0. Therefore, input voltage equal to 1 minus d times the average output voltage. The average output voltage V0 and average input voltage Vs are related as V0 by Vs equal to 1 by 1 minus d, or Vs equal to 1 minus d into V0. That equation 1. Now we are assuming the ideal element, switching elements as well as ideal inductor and capacitor, and assuming that one, we can get power, input power is equal to the output power, or V0 I0 equal to Vs into Is. Average voltage into the average current at the input side equal to average output voltage into average output current. And in that case, we can say that I0 by S equal to, it is equal to Vs by V0, which is equal to 1 minus d. or is input side current equal to I0 divided by 1 minus d. So these are the two equations. Input voltage equal to 1 minus d into the output voltage, and input current is equal to output current divided by 1 minus d. Equation 1 and 2. From these two equations, we can get what is Vs by Is. Divide first equation, divide 1 by 2. Then equating that, from this equation, we'll be getting what is the input resistance, or the resistance at the input side is given by that Vs, that is equation 1 divided by equation 2. Vs by Is equal to 1 minus d into V0 divided by I0 into 1 minus d, or here 1 minus d goes up. Therefore 1 minus d whole square into V0 by I0. V0 by I0 is the R out, this resistance R out, or output resistance, into 1 minus d whole square, or R out is equal to 10 ohms and d is given by 0.6. Therefore 10 into 1 minus 0.6 whole square, which is equal to 1.6 ohm. Therefore the resistance that is reflected on the input side is equal to 1.6 ohm. Now this is the case in the case of a boost converter. Now for other converters, the relation just you can remember that one. For a buck converter, the output resistance R out is reflected at the input side as R in equal to R out divided by D. In the same manner it can be derived. For example, then boost converter already we derived R in equal to R out into 1 minus D whole square. For a buck boost converter, the input resistance that is reflected due to an output resistance R out is equal to R in equal to R out into 1 minus D whole square divided by D square. Therefore, you have to remember, you can remember this one, so that directly you can apply that in this equation, so that you will be fine. You can get what is the resistance at the input side due to the load resistance or output resistance R out. Therefore, in this case, the answer is 1.6 ohm in a boost converter. Now let us see the third problem of 2021 gate question that also carry 2 marks. A single phase full bridge inverter by inverter fed by 325 volt. Therefore, this is equal to 325 volt DC produces a symmetrical quasi square wave across AB. This is the output waveform of this inverter. To achieve the modulation index 0.8, the angle theta expressed in degree should be, that modulation index is defined like this one. In this case, for the modulation index is defined as the ratio of the peak of the fundamental component to the DC voltage, to V, that is to this V, that is to apply to the DC bus voltage. Therefore, the peak of the fundamental voltage is to be derived in terms of D, and that ratio is called as modulation index in this context. Therefore, that is to be derived for that one. For in this case, in order to see, this is the inverter output voltage. This has got an odd symmetry, that is Ft equal to F minus T, as well as let's say half wave symmetry, Ft equal to F of minus of Ft plus T by 2. These two properties are there for this waveform. And in this case, A naught, then the Fourier constant, if you do the Fourier analysis for this one, Fourier constant, the DC component, that A0 equal to 0, and similarly An is also equal to 0 because of these two properties. Then what remains is the Fourier constant Bn. That too, only the odd harmonic will be present. Therefore, B1, B3, B5, etc. will be present. Therefore, we have to derive the equation for Bn, which is equal to, for this waveform, 8 by 2 pi integral, that is, this is taken as pi by 2, this one is pi by 2, or this is equal to 2d is the bit. Therefore, this is pi by 2 minus d, this is equal to pi by 2 plus d, pi by 2 minus d, pi by 2, from this one it is taken. This, because of the property we are finding out only up to this one, then this, because of this property, therefore that is integrate, that is found out until this point, that is the, because of these two property, that is to pi by 2 v sin omega t d omega t, or will be getting it is equal to 4v by n pi into sin nd. Therefore 4v by n pi into sin nd, where d is the, or 2d is the width of that one. Therefore this is the equation for Bn. Therefore to find out the fundamental, n is substituted as 1. Therefore here the equation for this one, Fourier, as the Fourier component based on that one, V0 equal to sigma n equal to 1, 3, 5, 7, etc. up to infinity, 4v by n pi sin nd sin omega. This is the Bn sin n omega t. sigma n equal to 135 up to infinity 4v by n pi. This is a 4v by n pi sin nd, that's bn. Bn into sin n omega t. Therefore, this is the equation for this verb form. Now continuing the same problem here. B0 we already derived. Sigma n equal to 1, 3, 5, etc. up to infinity 4v by n pi sin nd. This is the Bn into sin n omega t. Now to find out the fundamental one, we have to substitute n equal to 1. N equal to 1, it will become 4v by pi sin d sin omega t. Therefore 4v by pi sin nd sin. This is a fundamental one. 4v by pi sin d sin omega t if you are substituting n equal to 1. And the maximum value of the sinusoidal one is given by 4v by pi sin d. 4v by pi sin d is the maximum magnitude of this fundamental. So once you are getting the maximum magnitude in terms of the DC bus voltage, this is the DC voltage. 4v by pi sin d equal to the maximum value of the fundamental. So the peak amplitude of the fundamental component with a modulation index equal to 0.8, that is peak modulation index as it is defined as the ratio between peak value of the fundamental to the DC bus voltage, or this is equal to 0.8 times V. Therefore, peak value of this one is already given in the problem as 0.8 times V. Therefore, substituting this one in this equation, that is equating, that is here V01 equal to this one, and V01 also equal to 0.8 V, that's given in the problem. Therefore, we can equate these two things, or we can get 0.8 V equal to 4V by pi into sin D. Or from this one, we'll be getting D equal to 38.92 degrees from this equation. Or 2D, this width is equal to 77.84 degrees. Once we know this width, this is totally 180 degree, and this width equal to 77.84. Therefore, this one we can find out. The theta can be found out by this 180 minus 77.84 divided by 2. 180 minus 77.84 divided by 2, or 51.08 degree. Therefore, this theta is equal to 51.08 degree. That's the answer. Now, just to remember that one, if there is a pulse like a single pulse type of verb form here, and you can directly, this one can be remembered, this equation. That is, this can be written as the output verb form sigma, only the odd harmonic 1, 3, 5, etc., etc. 4v by n pi sin nd sin omega t. If you can provide that, this here, this is equal to 2d. It is this width equal to 2d. If it is width equal to 2d, then it is equal to sigma 135 infinity 4v n pi sin nd sin n omega t. You can remember this equation. Then no need of deriving like this one. Just remember for this one the relation of the output voltage in terms of different frequency components. Therefore, the answer is here theta equal to 51.08 degree. This angle equal to 51.08 degree. Now let us see the another problem, fourth problem, that is in 2021 gate question that also carry 2 marks. Consider the buck boost converter shown. This is the buck boost converter. Switch Q is operated at 25 kilohertz. Is operated at 25 kilohertz, and duty ratio is equal to 0.75 duty cycle. And assume diode and switch to be ideal. Under steady state condition, the average current flowing through the inductor is, what is the average current flowing through the inductor? That is the question. That is what. Therefore, this is a buck boost converter circuit as such. And here, when the switch is on, the voltage across the inductor is same as the input voltage. That is 20 volt is the that is coming across the switch. And since the voltage is across the switch is positive, the current is building up, because VL equal to L di by dt. When voltage VL is positive, L di by dt is positive, or di by dt is positive. That is why current is increasing in a straight line manner, in a straight line equation as such. And here the current is increasing from a minimum value to the maximum value, inductor current, during the switching on process. When the device is switched off, let us see what is that what happens. When the switch Q is switched off, what happens here? If the voltage across the inductor is equal to minus output voltage, means because here plus and minus comes, because the voltage inversion is for a buck boost converter. Therefore, the voltage across the inductor will become minus V0. Since the voltage across the inductor is negative, di by dt will be negative. That is why the current slope is having a negative slope. The current is from the maximum value it is reaching to the minimum value. Therefore, this is the inductor current that varies based on the voltage across the inductor. It will be during on period, the voltage across the inductor is same as this one. It is voltage current is building up, and during the off period of the switch, the voltage across the inductor equal to minus V0. Therefore, the current is decaying like this one. Now the question is that what is the average value of this current? That is what is the average value of the inductor current? To find out the average value of the inductor current, average value of the inductor current is given by, the method is that you have to find out what is the area under this, and you distribute that one over this time period. In order to find out the area under this curve or in this, we can find out it is equal to, this is just like a triangle. This is the area is just like a triangle, half pH. For half into, this is a time period, half into time period T into, what is this one? I max minus I minimum. That is the height. For half into, or TS, TS means the switching time period, half into TS into maximum value of the current minus the minimum value of the current, that is this area. Now below that certain this area is there, that is nothing but I minimum into TS. Therefore I minimum into TS, then that will be the total area. That area that is to be distributed over this time period TS, that is divided by TS. Then you will be getting it is equal to I max plus I minimum divided by 2. That is the average current through the inductor. Then average switch current. That in order to find out the average switch current, average current flowing through the inductor is the average switch current is nothing but, to find out if, average switch current here, that is here when switch is on, that is when switch is on, it is same as this one, the same current components. Whatever the current flowing through the inductor is the going through the switch also. Therefore, that is the same current is there. But when switch is off here, therefore the current is suddenly changing to 0. Therefore, this is the current through the switch. Therefore, the average current through the switch, same manner, we can find out the average current through the switch. What is the area under this one? That is distributed over TS. Therefore, that is again half into B is equal to T on only. Here it is available only T on. Half into T on, or that is equal to DTS. DTS means nothing but on period. Half into DTS into I max minus I minimum. That is this height. For that area plus this area is to be added. I minimum into this length DTS. For that is the total area under this one, that is distributed over TS, divided by TS. Now if you this one here, if you substitute in this one and TS gets cancels, or here we'll be getting I max plus I minimum divided by 2 or D, or meaning that the average current through the switch is equal to average current through the switch equal to D times average current through the inductor. D times average current through the inductor, or average inductor current equal to average switching current divided by D. For the question is that what is the average inductor current? That is, you can find out, first we can find out what is the average switch current, that divided by the duty cycle, then you will be getting average inductor current. So this is the inductor current waveform and this is the switch current waveform. Now let us see in the next slide. Now continuing the same problem, the switching frequency is given as 25 kilohertz. Therefore, the time period Ts equal to 1 by Fs, 1 by 25 into 10 raised to 3, or 40 microsecond is this time period is equal to 40 microsecond. And the duty cycle in the given problem, it is given 0.75. Therefore, the on period equal to D times Ts, or nothing but 0.75 into 40, or 30 microsecond is the on period, and off period equal to, of course, 10 microseconds. Therefore, the average output voltage is given by average output voltage equal to D by 1 minus D into Vs, or 0.75 divided by 1 minus 0.75 into the input voltage is given as 20. Therefore, that is equal to 60 volt is the average output voltage. Here 20 volt is the, here average output voltage equal to 60. Similarly, the average output current, if you see the average output current equal to, once you know the average output voltage 60 volt, average output current can be calculated, that 60 divided by the resistance, or that is nothing but 6 amperes. That is the average output current. Once you know the average output current, you can calculate what is the average input current. Average input current is nothing but, the relation is that average output current divided by average input current equal to 1 minus D. Therefore, the average source current equal to, or average switch current, that is equal to Is equal to, not 1 minus, D by 1 minus D into I0. D by 1 minus D into I0. Is equal to d by 1 minus d into I0. I0 we calculated here. I0 is equal to 6 amperes. For I0 by A is equal to 1 minus d divided by d. Therefore, here Is equal to, from this equation, Is equal to d by 1 minus d I0. d by 1 minus d I0. Substituting that one, we will be getting 0.75 divided by 1 minus 0.75 into 6 or 18 amperes. This is the average current through the switch. Again, the question is that what is the average current through the inductor? We already found out the relation between average current through the inductor and average switch current. Average switch current or average in the current through the inductor equal to average switch current divided by D. Therefore, average current through the inductor equal to average current through the switch divided by D, 0.75 or 24 amperes. So the average current through the inductor equal to 24 amperes and the average current through the switch is equal to 18 amperes. Therefore, the answer is here 24 amperes.